Alright, folks. I want to hammer in some more C++. Last time we left off, we were implementing a ring buffer in... I spelled that whole thing wrong. We implemented a ring buffer in C. Simple data structure. What I was thinking of doing, and I think it might be what I end up doing, is I made that in C, but I think it'll be much easier to do in C++ because I can just have the ring buffer be a class and all the functionality can be methods in that class. So I can either do that, or where did we leave off? Let me look back at my notes. I think last time we left off, we just wrapped up chapter 12. Let me just look really quick where we're at. Interview prep, C++. I didn't take notes on enums and structs nor classes, but you know what? I'm gonna take initiative here. We're gonna learn by doing, and let's go to interview prep and let's make a ring buffer.c++. Because what I want to do is have the okay. To get started, I'm gonna move the C code into the C++ file to start. It's just so much easier if I do that. Okay. So we want a class called I might even be blanking on syntax here. No, I'm not. Let's make a ring buffer. In it, we will have the only thing that's private is gonna be this struct. I'm just verifying syntax really quick. Yeah, I didn't think. Oop. Okay. And we can just have this as RB. Okay. Now that we have that, this will be a private structure. Oh, come on. I gotta do it again? Okay. So our ring buffer should be the only thing that is private. We can make a constructor for this. So we have ring buffer. Do we need the struct? I don't think we need the struct. I don't think we... Wait, let me think about this. I don't know. We can make these all private, but... Well, okay. Actually, to start, let's just have it here, just in case. And then we can comment it out if we ever need it. Okay. And then let's just do this. Okay. Alright, cool. Now, what's public is going to be, we're going to have a public constructor taking okay, I'm gonna try something. I think we should be able to take a size T buffer size, and this will make buffer int buffer of size. And just to, let me go to the deck of cards. Interview questions. Deck of cards. Okay. So we have that struct. We have our deck of cards. This is our I see it. Okay. Alright, yeah, we can do this. Buff start okay, I'm curious on how that's gonna work, but buff start is gonna equal buffer. It's gonna be the init, but it's gonna be in the constructor. Was kind of my thinking. Buffer plus size. Data start equals buff start. Data end is also going to equal buff start. Okay. So that's our constructor. Cool. So now we can get rid of this. Okay, yeah, that worked. Next, we'll just take the is bool is empty method and put it in here. Return data start equals data end. Cool. Then we'll do the same for is full. Return if data end plus 1 equals equals the buffer endpoint. If it does, then we return the buffer start location. If it does not equal the buffer endpoint, then we just increment the data end pointer by 1. And then that's a return, but we want this to check if it's equal to our data start point, because that's how we know they will be a full buffer. Okay. So these two we have implemented. It's a good place to check if this works. And let me fix my spacing really quick. Actually, I'll fix my spacing before next recording. Because it keeps bothering me that I don't have it done. Okay. I think we start with this. And just do some initial testing. So my main concern is that this initializer won't work because it's not defined anywhere else. And I'm not sure how to allocate that space correctly. Because after initialization, let me look up something. Vector initialization, and then set size after. C++. Okay, we can do resize. Oh, but I think we can do this in a vector. I'm willing to bet. Okay. std vector buffer. Making this an int. And then in here, we will do buffer dot resize to size. Cool. Let's go to the top. Let's take out all of these because those aren't the right header files. Include iostream. Include vector. Vector, oh yeah. I just want to check ring buffer named RB. I want to check if RB dot is full. And then we can do the same for is empty. emty. Cool. And then I think we'll just have to comment the rest of this out, but that's fine. Okay, let's do a quick review. So we're using a vector as the buffer. We set the size for it in the constructor. And then we have pointer locations to it. We can use a vector because this is contiguous in memory. So I'm thinking, right? Let's just double check that. Are C++ vectors contiguous? Yep, okay. We can use this. I was 99% sure, but you can't say wrong things online. All right. Let's let us see what's going on. Okay, I was like, our code compiles? No matching function call for. Okay. Cannot convert. let me look into this for 1 second. Do I have to just do begin? Okay. I will make a note to review vectors in more detail, but essentially what I need to do here is do buffer.data. And then this will be buffer.data plus buffer.size. And then data start will be buff start and buff start. Yeah, so those are both int pointers. Okay, let's recompile. No matching function call. Oh, I'm not giving a size. Oh, we should have a default arg. And in our constructor, I also want to, just as a sanity, print out the size. Buffer.size. Cool. Size is 5, is full as 0, is empty as 1. Okay. All right. So now let's add our read and write. So we'll have bool write. We need data. This is, yeah, C++ makes this so much easier. Because then we can just do, we're in the class, so we can just call isFull on this directly. We might need this. Okay. Call might be problematic. Let's just jot that down in debug for later. Where's my mouse? Where's my... Okay. Okay. Now... There we go. Okay. If is full, return false. Easy. Okay. If not, we want the value at buff. Wait, no. Not the value at data start to, no. Data end to equal data. Then we want to increment our data end. Gosh. Yeah, see, we have to do all these like structure pointer calls in here and pass in the ring buffer object itself in C. This makes it so much more palatable. So data end plus 1, if this equals the buffer end, then we will wrap around and return the buffer start. And then if it doesn't, we will just increment our data end pointer. So that's our right. Oh, we also want to return true. And then let's just copy this. All right. Now we want to read. And this will be to a data pointer. We want to check if it is empty. Then we just want to flip this. So we'd want the value at the data pointer to equal the value at data start. And then we just want to increment the start pointer. Wait. Okay. I was confused. Okay. So this is the exact same. It matches with this. Okay. We have our logic. Print buffer would be good to have. Yeah, I guess we can do that for auto I in our buffer. Printf. Nope, not printf. That is wrong. I equals 0, or I equals I. Okay. Alright. This looks good. Then, first let's just make sure this compiles first before we... Alright. So... First thing we want is to write 5 values to it. Check if it's full. And so that'll default. So we're fine. We won't read just yet. I want to start here. Let's see it. And we talked about this before. The reason we can't fill all five regions with this buffer design is because if we fill that last spot, then the end pointer for the data increments to the start location of the data. And with our current logic checking, that qualifies that the vector or the buffer is empty. There's a workaround using a Boolean flag to qualify whether it's full or it's empty for this given case, but I think I like the way this plays out a little bit more. And then okay. And is full is true. Yep. That's what we want. Now we will have this int val, and then why not? While RB is empty is false or true. Wait. While bang RB is empty, read RB.read. You don't need to pass in the address anymore. And here, let's pass by reference. Let's pass by reference so we can just do this. Why not? We need to use some more skills. And let's do the same here. Why wouldn't we? Oh. There we go. Alright. We'll read those values, then okay. I think I'll just have it run all of this, but I just need to RB dot is empty, 1, 2, 3. RB dot read. This is pretty freaking cool. I'm liking how this is turning out. Can we use printf interchangeably? Oh, we can. Oh, thank goodness. I didn't want to change everything. Okay. We've RB read. Then we'll write again. Oh, my thinking is I plus 20 is going to be an R value. My thinking on that is it can't be a reference. I really hope I'm right there because that is some crucial knowledge. But I think I'm right. I think I'm right about that. Just kind of reading this all over really quick. That looks good. We're reading everything, then we're trying to read again, but those are going to be empty. Sure, why not? We'll print the buffer after we read it, or write everything again. Cool. Alright. Let's compile. Oh. I knew it. Non-const reference. So the writes can't be. Makes sense to me. Cool. Okay, let's walk through this. Let's also cat the code so we can just review it right here. Oh, that's a lot more code than I thought. Alright. So we're gonna write 4 values, because that last one won't pass. So it'll be 10, 11, 12, 13. We see that here. And it's full. Then we read until it's empty. So we read 10, 11, 12, 13. We read all the values out of there. Then we empty, empty, empty. then, sorry, I was thinking through in my head if we need to add a destructor. But hang on, let me look that up. I think it will be good to just create the destructor just to have that practice. Okay, so we read these all. Then we have these empties. Then we're gonna write 4 more. So it'll be 20, 21, 20, 21, 22, and 23. Those, I believe all of those should write. Unless I'm off by 1. Wait. Print buffer. Where am I printing the buffer? I print it here. 21, 22, 23. Why didn't we overwrite 13? Why did we write after 13? So hang on. If we look at this, if we try and write 1 more, what are we looking at? It won't write. So what I'm trying to do is let me think about this. I get why. Never mind. That makes sense. What if we want to do what I'm thinking of? We need to read 1 here. What the heck? rb.read to val. And then we need to rb.write, and we want 24. So this should replace this 13. Let's see. There we go. That's what I wanted. All right. And then really quick, let's just add the destructor. How are we doing on time? Okay. We're doing okay on time. I opened the wrong file. Okay. Then let's add the destructor. Ring buffer. I just want to add a print statement that we are exiting the stack. Cool. And I think what makes sense is to also add I think what makes sense upon oh no, this all gets torn down. I was gonna say we should realign all the pointers, but it's being destructed, so nothing's gonna point to anything. All right, cool. Let's add that project in. Using a class, ring buffer class, so much better. Cool. So that was kind of the only thing I wanted to fully dive into. My thinking on what comes next is a producer and consumer task, right? Because we already have our read and our write pointers. So my thinking is we have a producer that will, let's add the ring buffer here. Looks like a little donut. And then we'll just add some sections. So my thinking on what comes next is we'll have a producer write to this. That's a terrible W. I'm learning MS Paint. Bear with me. And then we will have a consumer read from the buffer. And the thinking is this will kind of be protected by a mutex. Now I think what makes sense is we implement the mutex ourselves. But how a mutex works is it's essentially a key for a locking mechanism. So how it works, and this will be another class that we make, but I think going from here, I'll do everything in C++. That alone was so much easier to integrate and interact with the class rather than calling on the structure to exist and everything. That was much better. Obviously, still need to hammer down the even the vector initialization and resizing APIs. But anyways, I digress. Essentially, a mutex will start with the value of 1 if and it's a value of 1 if no one is holding the mutex. Now, what calls the mutex to change its value is this .lock. And this .lock, I also believe we can use the this is kind of like poached from getcracked.io. They have a producer consumer problem where without using the mutex library, you need to implement a single producer consumer problem or mechanism. So what happens is a mutex is atomic, meaning 2 actions on the data structure cannot happen at the same time. They have to be distinct time slots. So what that provides us is determinism that a producer and a consumer thread won't be interacting with the same lock mechanism to essentially hold on to the mutex at the same time. Because imagine if we didn't have the atomicity, I think that's a word, feature for this. What could happen is both of these are trying to lock the ring buffer in order to change its state. The consumer is going to pop an item off, and the producer is going to feed an item in. So if we don't have the atomic nature, both of these are holding the mutex at the same time. And then one can be writing in the location where the other's reading, and this is called a read-write conflict, where it's completely undefined behavior of the given result because there's no control over that space. So essentially, interacting with the ring buffer is going to be our critical section. And the critical section in the embedded systems world, which is what I'm studying, the critical section is what you protect via semaphores or a mutex. and mutex I should add stands for mutual exclusion. So I'm a lefty, so I'm thinking it's hard with my right hand. Mutual exclusion. So we essentially want to lock down the mutex before our critical section, and then we want to free is probably not the right word, but let go of the mutex after her critical section, after we've interacted with the ring buffer. I'm gonna save this diagram. Probably not, it looks disgusting, but you get the idea on these next steps. Is we have the data structure class, and now we will need the mutex class, and a producer and consumer are going to be distinct threads interacting with the buffer. So the distinction here is the current implementation. These read and writes that we're doing, these are all segmented. We know what order they're going to execute in. When we have threads, there's this notion of concurrency, where the processing unit is going to be jumping between instructions on distinct threads in order to have better efficiency in processing. When that's the case, let's say we start a producer and consumer thread here. We don't know which one's going to go first. We could write first that the producer is going to write something to the buffer, but that's not guaranteed on how that actually plays out. So that's again why this mutex is so crucial, is because once you implement threading, maybe I can shout out this book as well that I'm going through, but this POSIX threads book is all about like safe concurrency handling and stuff like that. And if you're not locking down that mechanism, a lot of things can go bad. So yeah, I hope this makes sense. For any viewers, leave comments, thoughts, whatever. Obviously, still learning C++, but the Learn C++ tutorials are great, but they only get you so far, and to be quite honest, it feels at some point like tutorial hell all over again. So just trying to more and more learn by doing with some more simple, relevant examples. All right, well, that will be all. Cheers.